Hello there, it's Mr. Wicklehouse, and today we're talking about solving systems of equations by graphing. Sorry, I try to change my voice up every once in a while just to make things more interesting. We are starting this unit off, by graphing some stuff. It should be pretty easy and it should be reviewed for you. That being said, let's get going. Alright, system of equations. What's a system of equations? System of equations is multiple equations put together. And the idea is that we're looking for a relationship between these equations. So you might have a system of equations and it'll look something like, might look like that, and it'll be like x plus 2 and equals y, well, let's just do it this way. Y equals x plus 2, and then, let's see, 3x plus 1. You might see them look like that. Sometimes they'll just be simple, written like this. You could have more than 2. You know, it just depends on what's going on. Okay? So there's 3 possibilities for these relationships between these two systems. The first possibility is that when you're looking at the graph of these equations, then they will intersect at a certain point. So you'll graph these things. Here's your graph, your little graph. And then one will be going like this. One will be going like that. And then the solution here to these is at this point right there. Okay, so that would be the solution to that system. The next relationship is that the equations are equal to one another and they will look the same on the graph. So if I'm graphing these guys, then I'll have a graph here, and I'll graph one line, and then I'll go to graph another one, and it'll just lay right over top of this one. And a lot of times when that happens, we'll say that there's an infinite number of solutions. Okay, because they're the same, so there's an infinite number of points where that intersects. This one, there's just the one solution. Okay. The last is that there's no relationship between the equations at all, and they will not touch. Okay, so with that, something like that might look like this. So if we're dealing with lines, then we've got a line, and then the other line that we graph will be parallel to the line. So it'll look like that. They're not ever going to touch, so on and so forth. Okay. Now lines are not the only system of equations that we could have. We could have things like parabolas, like this. Could be like something like this, where you'll have more than one solution, but not an infinite number of solutions. And, you know, pretty much anything, any kind of equation or function that your little mind can think up of. Okay? All right. Moving on. So, when we're solving these, we graph each one of the equations. Okay? And we graph them on a coordinate plane and look for the point where both equations have the same solution, an infinite number of solutions, or no solution at all. The solution is the point of intersection, like I said before, and you need to write that solution as a coordinate point with an x and a y value. Okay? Don't just tell me that x equals this and y equals that. You need to put them together as a point. Most of what we are doing in this unit will involve relationships between lines, but you can look at other systems as well that involve things like quadratics, parabolas, you know, that kind of stuff. So most of what we'll be doing when we're graphing these is using our slope-intercept form of our equation, or the y equals mx plus b. So you need to be able to remember how to graph these guys, okay? And that's the most important thing when we're doing this. All right. So let's do a couple of examples. So we want to get both of our equations, or however many equations we have, in slope-intercept form. Okay? These two have already been given to us in slope-intercept form, so I'm just going to go ahead and graph them. Well, this one here, I know that my slope, or m, is equal to 2, and my y-intercept is equal to -1. So I'm going to come down here to -1, draw my point. Since my slope is a positive 2, then I'm going to go up 2 and over 1, and then I'll go down 2 and over 1. Okay? So there's some points. Now let's go ahead and graph this. I'm going to use my piece of paper here as a straight edge just to make it a little easier for me to graph it. I'm just connecting the dots essentially. So we'll go up this way. There we go. Go down that way. There's our line. Now let's graph the other line. So this one, our slope is 3. This one, our y-intercept, is -5. So I'll come down to -5. There's 1, 2, 3, 4, 5. That's going to be my starting point. Slope of 3 means I go up 3, 1, 2, 3, and over 1. And down 3, 1, 2, 3, and over 1. Then I'll graph my line. Okay? And I'm going to use my nice little piece of paper to get my straight edge here to make it a little easier to graph. Go all the way up. I could go all the way up through here. You might want to use a ruler instead of a piece of paper. I meant to have a ruler with me when I did this, but I don't have one with me right now. So there's our two lines, and we could see that this is meeting at that point right there. And that point is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So my solution to this is going to be the point 4, 6. Okay? So as easy as that. So graph your lines, find the point of intersection, and that point of intersection is going to be your solution to your system. Okay, here's another one. Remember, looking at these two, you can see that these are in standard form, right? Standard form. So let's get these into slope-intercept form. So I'm going to add 2x to both sides. I've got 4y equals 2x minus 8. Divide by 4. I get y equals 2 over 4 is 1/2 x. 8 over 4 is 2, so minus 2. Now here's this one. Let's get this one the way we want it. We're going to add 4 to both sides, so we get 3x minus y equals 8. Subtract the 3x, we get minus y equals minus 3x plus 8. Then I'm going to multiply by negative, which will make this positive, make the negative 3x positive, and make the 8 negative. Okay. So now I've got my two equations in slope-intercept form. Okay. So my slope on this one is going to be 1/2. My y-intercept on this one, excuse me, is going to be -2. Slope on this one is going to be 3. Y-intercept on this one is going to be -8. Okay. So let's graph this one first. go down here to -2. There's my first point, and I'm going to use the slope of 1/2, which means I go up 1 and over 2, down 1 and to the left 2. Okay, there's my first line. Let's get that guy drawn. Okay. Using some kind of straight edge to make my line as straight as possible so that I can get the best solution possible here. Okay, there's my first line. Let's do the other one. -8, -2, 3, 4, 5, 6, 7, 8. And then slope of 3, so up 3, 1, 2, 3, over 1. I'm not going to go down 3 this time, I'm just going to go up 3 again. 1, 2, 3, over 1. Okay. I'm going to use my straight edge again. I'm going to graph my solution here. And here is my solution right there. Okay. So that solution is going to be, it looks like it's about, oh my, it's in a crazy spot. Let's say about, this looks like about 2 3/4, and this one is about 3/4, -3/4 for a y value. Okay, and that is how we would do it. Okay, so you're just graphing each line and then finding out where they intersect at, and that's all there is to it, guys. All right, and I will talk to you later.